And that is the latest sunspot. It's pretty huge. It's pretty exciting. We'll be talking more about it and lots more on today's Daily Space Weather video. Most of the activity coming from the northwestern limb, actually. So thanks for tuning in to the Smash News Network, least busted name of news. And let's get back to some solar imagery. That's the last 24 hours from the Solar Dynamics Observatory. Let's switch to a composite view here. This is also including 171 angstroms, but it also includes 304 and 211 angstroms. Lots of filaments. Likelihood of CME is very high. Check out this filament reorganization happening right here. A little bit of filamentary migration happening there. And here's yesterday plus today intensitygram. Some umbral consolidation happening in this sunspot here. That's sunspot 3098. And this re-emergent giant sunspot group down here, it'll be known as 3102 or maybe 3103. I think 3102. Here is the colorized magnetogram from yesterday plus today. And let's talk volcanoes for a brief moment. See what's erupting. Shivaluch, probably erupting, but volcanic ash not identifiable in satellite imagery. Sakurajima, flight level 090. Mount Ibu, flight level 070. That's a 7,000-foot plume of volcanic ash. Samaru exploding, 14,000-foot ash plume from Samaru. Dukono exploding, flight level 070 from Dukono. Popocatépetl exploding intensely. 24,000-foot ash plume there, one of the largest eruptions in the world there in central Mexico. Fuego in Guatemala, 15 to 16,000-foot volcanic ash plume accompanied by Vulcanian and Strombolian activity in Guatemala. Nevado del Ruiz, no volcanic ash observed. Don't assume it's not erupting. Sangay in Ecuador, 24,000-foot ash plume as it explodes. 17,000-foot ash plume from Revenador as it explodes. It's a flight level 170. Flight level 240 from Sabancaya down in Peru. That's your volcanic rundown. Here's your seismic report. That's a 90-day bar graph there, following the 7.6 magnitude quake at Papua New Guinea, which we reported on the tsunami possibility before USGS even got their warning out. More on that at smashomash.com/smashteam. So here's your earthquake rundown for the past 24, and nothing larger than a 5.2 like that 5.2 at Papua New Guinea. Looks like an aftershock. So things fairly calm here over the past 24 hours. Iran saw a 4.8. Not the most common place for a quake. 5.2 at Japan also. .0 at the South Sandwich Islands and a 5.0 at the Fiji Islands. So again, pretty calm here over the past 24 as far as earthquakes go. So here's the last 24 hours in ionized helium. Once again from the SDO. And let's zoom out a little bit and take a look at some coronagraphs. Are you wondering if any coronal mass ejections have happened? Well, we'll answer that early. So here's a zoom out showing the LASCO C2 and the LASCO C3, part of the SOHO spacecraft. You can see the solar wind has been pretty calm here over the past 24 hours. No major CMEs to note. The 10.7 centimeter radial flux has come down to 150 solar flux units. We are sort of expecting to see this rise again here, but hey, who knows what'll happen. No forecast there on the radio flux, but there's the 1-year graph. Radio flux now at 150 solar flux units. And if you're wondering what a solar flux unit is, it's 10,000 joules of radio flux density. Discovered in 1947 by Canadian radio astronomers using some World War II radio equipment. Space Weather Enthusiast dashboard not showing any forecast for any geomagnetic unrest or storm conditions. NOAA expecting geomagnetic calm for the next 3 days. And here's the geospace magnetosphere movie for the past 4 hours, and that very low pressure is a result of very low density solar wind. Solar wind density so low at the moment that it looks like errors. But assuming that data is correct, we've got a quite low pressure environment around the planet here, at least for the past 4 hours. And most of the last day, indeed. Again, if the solar wind density is as low as it's actually read. So this is a model, space weather modeling framework, magnetohydrodynamic pressure over the last 4 hours. Here is Earth's magnetic moment from the ground. Geospace delta B is a reference to changes to Earth's B field, scaled here in nanotesla. And like the last frames, that is the last 4 hours. KP index here now up to 2. It was at 0 there for 6 hours to start the day today on September 13th. And here's the real-time solar wind data, and you can see these error bars down here, likely expecting to be errors there as we see the solar wind density dropping below 1 proton per cubic centimeter. Getting very low there. Current conditions reported as 0.6 protons per cubic centimeter. Solar wind speed here pushing 300 kilometers per second there, shown as only 317 kilometers per second. Magnetic field looking weak also. It's a BTBZ of 4 positive 1. So 4 nanotesla is the total field strength. Positive 1 is the BZ, the vertical component of that. So weak conditions here as far as the solar wind. There's a lot of empty space between Earth and Sun at the moment. There are your GOES magnetometers for the past 3 days as measured by the GOES 16 and GOES 17. And we are seeing the electron storm subsiding. We'll get to that toward the end of the video. Let's take a look at the heliospheric current sheet next. Earth lies in a South Pole current sheet, shown there in red. North Pole current sheet there rotating away beyond stereo B, which is this little plus sign right here, by the way, located at Lagrangian point 4. Next, the line of sight plot. The sun's fields here shown in red and green. The B field, the field that goes through the magnet, this magnet being the sun, shown in blue. And let's move to coronal holes. So we're going to cover cosmic rays today. Give you a little bit of information about cosmic rays that you may not yet know. Here's our line of sight coronal hole plot, and you can see South Pole oriented coronal holes here rotating in. Some North Pole coronal holes down there in the southern hemisphere also. So we've got a mixture of North and South Pole coronal holes at the moment. These coronal holes down here in the south, these are North Pole oriented. These more well-defined ones in the north, they are South Pole oriented. So you're seeing the solar polar field reversal process happening now. It's taken its good old time, especially the North Pole, which is still mostly fixated. Well, it's still at least partially fixated at the North Heliographic region, the North Heliographic Pole. And before we get to sunspots, let's talk about cosmic rays. So you may or may not be aware of the Forbush effect. Let's briefly talk about it. The Forbush effect, widely believed to be caused by the sun's magnetic fields being projected out farther into the solar system, lowering the amount of cosmic rays. In other words, cosmic ray flux is inversely proportional to solar activity. You could look at numbers like sunspot number or the radio flux and say that those are typically inversely proportional to each other. In other words, cosmic ray flux is high when solar activity is low, and when solar activity is low, cosmic ray flux is high. We see this going back at least 1,000 years because of some tree ring data looking at things like isotopic ratios. And of course, cosmic rays come from outside the solar system, and indeed even outside the galaxy, perhaps. Fast-moving protons, fast-moving galactic nuclei with no electron, some of which make it deep into the Earth. And they cause, of course, ionization pathways to form via their particle showers when they strike the magnetosphere. And as they get lower and lower in the atmosphere, they are more likely to create a particle shower and secondary particles and isotopes and ionization pathways. That's a little bit about cosmic rays. They seem to have something to do with climate. And if we see very high cosmic ray flux, the Earth could get cloudy all of a sudden. I know it sounds strange. Cosmic rays seem to be associated with climate. So we'll just leave that there. If you want to read the article, it's on Britannica.com. So check it out. And you can say some of the proton events are indeed cosmic rays from the sun. So let's take a look at the last 30 days here on some various different cosmic ray monitors. The Apatity Neutron Monitor, they're showing a significant uptick over the past 30 days. You might have expected to see a downtick here with the increase in solar activity, but indeed, cosmic rays have gone up over the past 30 days at Apatity. Next, Barentsburg, showing practically the same graph there, an increase in cosmic rays at Barentsburg. Okay, let's go someplace farther south, like, I don't know, Athens, Greece. Let's check Athens, Greece's neutron monitor, and seeing almost the same graph there as well. An increase in cosmic ray flux over the past 30 days. Interesting. Let's go even farther south. There is the Mexico City Cosmic Ray Observatory, and that also showing an uptick for the past 30 days. Let's go back up north to Oulu, Finland, and seeing nearly the same graph there. An uptick at Oulu also over the past 30 days. Now, one thing great about the Oulu chart is that it does show you the historic cosmic ray flux. You can see the lowest ever measured was around 1991 during a significant solar maximum. And that graph dating all the way back to 1965. If you do line that up with solar activity, you'll see that it is quite inversely proportional to sunspot number. And I would keep in mind here, folks, that we are not at the cosmic ray maximum. We're well below that. And we're actually already approaching the cosmic ray minimum of solar cycle 24. But over the past 30 days, an uptick in cosmic ray activity. Going as far south as we can get to DOMB Antarctica, showing practically the same graph, an uptick in cosmic ray flux, and DOMB, an uptick in cosmic ray flux. I find it quite interesting, and you may too. Our gold members may find it even more interesting. Consider supporting the channel if you'd like via a subscription membership at smashomash.com/SmashTeam, especially at the gold or silver level. There is also a bronze level, which costs you $0 per month. All kinds of other links there as well. smashomash.com/SmashTeam, where we put up content that we don't put anyplace else. We put it on our own subscription services website. And thanks to the Smash Team. You can find links to that and lots more at smashomash.com, our homepage. And welcome to the Neo Renaissance. We are in the process of composing a paper to explain the solar sunspot and solar polar field reversal cycles. We haven't forgotten about it. I'm just working like 53 hours a week, and that reduces my ability to produce additional content. However, we still are putting out additional content. You can find all kinds of links there as well, like links to our SureMed page. Improve your health by becoming a member of the American Better Health Organization, otherwise known as SureMed. Got all kinds of features like discounts, and better yet, doctors by phone, counselors by phone, virtual veterinarians, health advocate solutions to help you negotiate lower bills and find service providers, and so forth. A membership at SureMed is not insurance coverage. It's an association, a nonprofit agency known as the American Better Health Organization Incorporated. Improve your health. It's certainly worth the $20 a month. I'm a member. I've actually used the doctors by phone service a few times myself. It's fantastic. They'll call in your prescriptions, which you can also get a discount on with your SureMed card. Links below the video and on a Twitter page. Twitter.com/SmashoMash. Thanks to our new followers over there. Congratulations on realizing our channel exists. If you don't have a Twitter account, go create one. It's completely free, and you can interact with all kinds of interesting people, despite the fact that various other interesting and uninteresting people have been banned. I know, the censorship's pathetic. Create an account anyway, and hold Twitter accountable for their pathetic censorship on their own platform. Yes, they mislead investors, just like Google, Apple, and Facebook, otherwise known as Meta. Google, otherwise known as Alphabet. Thanks to our Twitter followers, our Twitch followers. And if you haven't checked out the merch shop, check it out. It's pretty sweet. Links below the video and on the homepage to the Smasho merch shop. Today's featured product is Forgive, Remember, and Hold Accountable, because holding a grudge is like ingesting poison and expecting the other person to die. So don't do that. Forgive, remember, and hold accountable. Forgive and forget is so 2019. Do nothing of the sort. Forgive and forget. Why would you forget? Don't be shartlit on the internet. Do be shartlit, just don't be gaslit. Lots of people out there shartlighting, and if you want to know what the definition of the word shartlight is, once again, find out on twitter.com/SmashoMash. Whatever you do, don't hold a grudge. Forgive, remember, and hold accountable. And thanks to our new subscribers over on YouTube. Thanks for putting up with the pathetic censorship on the YouTube platform. Check our playlists for things like music videos, terms defined, the Diamond Anvil Too Hard to Smash, and lots more, where we talk about all kinds of things besides daily space weather and meteorology. Thanks once again to our YouTube subscribers. Let us know what you think of our thumbnails. Are those not the sweetest thumbnails in the realm? Anyway, once again, thanks to our subscribers over on YouTube. Congratulations on realizing the channel exists. Don't forget to press the share button. Leave us a comment. Tell your friends and foes about us. And let's get to sunspots. So again, this sunspot needs a name for sure. That's going to be, I think it's going to be known as 3102. It's quite huge. It's not as magnetically complex as 3098. That's where the main activities come in the past 24 hours, and let's move on to take a look at some close-ups. And a little bit of evolution of sunspot 3098 happening. And here it is up close and personal with an Earth scale. Oh, wait, first, 3102. And these groups up here may get named also, so that there may have 3102, 3103, and 3104, but certainly this sunspot's going to get a name. And it is appearing to be Beta Gamma class, as there is a trailing umbra there. Right there, just coming into view. So here's the most interesting part of the sun here. The most active over the past 24 hours has been 3098. You can see that umbra there, just about the same size as the Earth, as it consolidates its fields a little bit. A little bit of migration there. The leading North Pole portion rotating a little faster than the trailing South Pole portion. Proton flux here still starting to drop back down to baseline following a minor proton event, causing a little bit of polar radio blackouts. And there's the flaring profile. One impulsive flare here happened, an M class, just before midnight. It was an M1.7. M1.78 was the magnitude of that flare. And let's take a look at the sun in 94 plus 131 angstroms. So there's the 94 angstroms for the past 24 hours. See that M-class flare happening. And here's 131 angstroms. And we're going to show you some extreme close-ups of that northwestern limb. Don't be surprised at all to see Sunspot 3098 produce an X-class flare as it sets. It shows no sign of evaporating. So if it sets in the kind of mode that it is now, an X flare is somewhat likely. And let's zoom out here and take a look at a star chart. We're always interested in what's going on overhead. We've got Jupiter, the Moon, Mars, and Venus above our heads right now in Lehigh Valley, Pennsylvania. If you want to make your own star chart, it's in-the-sky.org. We've included the galactic plane there, shown in blue, the ecliptic in yellow, as Cygnus sets in the northwest. Did you know that that star in Cygnus is the only known cosmic ray point source? Yeah. Deneb? What is going on? Yeah, Deneb, this star right here. That is the only known cosmic ray point source. It's a massive X-ray binary consisting of a blue supergiant Wolf-Rayet star orbited by a more compact object with one of its stellar jets pointed directly at you. The brightest intrinsic object visible from our solar system, the star Deneb, the tail of the swan. Next, a solar system forecast. Here's where things are now. We'll advance it 1 week. We will have a crescent waning moon by the 20th of September, as all the planets are on one side of the solar system except for Venus, the third brightest object in the sky. Next, some coronagraphs. Here's yesterday. Fairly uneventful in terms of coronal mass ejections. And here is today's imagery. That's 26 more frames. We'll also show Stereo A located at Lagrange 5 and the SOHO-LASCO C3 located at Lagrange 1. Actually is 1 CME here. It is on the far side of the sun. That's all the way from back on September 11th. So things quite chill here in terms of coronal mass ejections. And we are expecting some, as there is a huge number of filaments. Huge number of filaments right now on the Earth-facing portion of the solar disk. If you're wondering what that bright object there is, that is Venus. So here's a zoomed out view. The last 24 hours, SDO 304 angstroms plus the SOHO-LASCO C2 and C3. I'll let that play through one more time for you here. And here are those filaments I was talking about. You can see all those dark absorption features there in hydrogen alpha. That's the ground-based solar observatory at El Teide, Spain. Huge number of filaments and some huge filaments. And remember, folks, you don't need to see solar flares or sunspots to see coronal mass ejections. Here's Here's the last about 2.5 hours from the Ghost 16 SUVi. This is what we typically stream all day long on Twitch. The channel is twitch.tv/smashomash. Install the mobile app. It'll actually alert you when we go live. Unlike certain video hosting apps, which barely function, Twitch functions quite well, and you'll find that in the realm of computing, if it's good enough for gamers, it's good enough for any computing functions. Keep an eye on both the northwest limb and the southeast limb. It's where the action is at. Here's the last 24 hours in 171 angstroms. The house favorite looks like another active region rising up here in the northeast. So exciting stuff going on once again on the closest star. And it's time to do bonus features. To talk about things like satellite charging hazards, which are now quite minor. Only a little bit of surface charging here as the electron storm wanes. A little bit of surface charging hazards there over Mexico, moving into the central Pacific Ocean, caused by low-energy electrons building up on the surface of satellites. No big deal. There's the electron flux measured by the Ghost 16 and Ghost 17 over the past 3 days. And the NOAA forecast nailed it. The green boxes are the forecast, the yellow diamonds are the observation. As we come off the highest electron flux we've seen all year. There's the 1-year graph to put that in context. We'll also show the F ionosphere layer, the vibrational frequency of the bridge between Earth and space. It's located at about 300 kilometers of altitude. And there is the ionosphere's vibrational frequency, the ionogram, as we call it, courtesy of Australian Government Bureau Meteorology. And quite a lot of high frequency anomalies in the southern hemisphere. As you'll see here on the anomalygram, also some wild swings there around the equator, around South America, which is not all that surprising, due to the South Atlantic anomaly, which is now over the South American continent. The weakest point in the Earth's magnetosphere is right about here. There's also another weaker spot down here, but this spot right here is the weakest spot. So 2 weak spots there, one around southwestern Africa, one around central South America. And you can indeed see evidence of that with those wild swings of the ionospheric anomaly. That's anomaly in megahertz from a 30-day median. And there's the latest image, 10:30 Universal Time. Some polar low-frequency anomalies happening in the north. We'll also show the electron content. Total electron content forecast shows the electrons present in the plasmasphere, the Van Allen belt, the lower plasmasphere, and the ionosphere, which can cause GPS errors of thousands of miles. Here's a total electron content forecast. And things still looking fairly organized here. Nothing too crazy going on there. Let's take a look at the latest intensitygram and latest colorized magnetogram to check the state of affairs with this new rising sunspot. Sunspot 3102, I believe is what it'll be called. There are the magnetic fields, and you can see it's got a leading South Pole umbra and a trailing North Pole umbra, so it is beta gamma class. We'll also take a look at this group. (3098) beta gamma delta class. Again, don't be surprised to see that one produce an X-class flare as it approaches the limb. Also an active region rising up here. It's a little bit too early to see that, I think. Here's the rock back. And let's bring up one more series of images here. This is Iron Star. 3 different species of ionized iron, 335, 193, and 94 angstroms. At data from yesterday plus today. As we show the most detailed imagery of the sun anywhere on the internet and the most comprehensive space weather in the world. Speaking of the world, it's time for station identification and to move to the realm of meteorology. So the first thing we're going to take a look at here is sea surface temperature anomalies and ocean currents. So that's what we've got there on the map for you. Very hot water there in the North Atlantic, especially the Northwest Atlantic. And do you see a lot of cold water being injected into the North Atlantic here from Greenland? I certainly don't. If you think the Gulf Stream is going to be shut down, which is going to shut down the AMOC, if you think the AMOC is going to be shut down, the Atlantic Meridional Overturning Circulation, it's just not being shut down. Europe has not seen a year without a summer. Grand solar minimums canceled. Stop telling us Europe's going to freeze. It simply isn't. All the ridiculous forecasts are based on nothing, and keep in mind, folks, the GFS model is unable to forecast beyond about 3 days. You really think you really think anybody's forecasting 30 years of climate? Really? Really? Anyway, the Gulf Stream is alive and well. And the water is anomalously warm there in the northern portion of the Atlantic Ocean. I mean, we're talking 6 degrees, 8 degrees above normal there. So some warm water, some cold water mixed in, very cold water right there. That's 4 degrees Fahrenheit below normal. And check out the cold water left around Baja California following that hurricane strike. 5 degrees below normal there at Baja California. Anyway, not to leave anything out, we'll show the whole planet in terms of sea surface temperature anomalies. The western Mediterranean looking hot. The northern Indian Ocean looking cold. Central Pacific looking cold. The rest of the Pacific looking a little warm. Here are the surface winds of the eastern world as the China coast continues to be threatened by this typhoon. It's just loitering there. And at least 85 mile per hour winds. Probably more like 100 mile per hour winds there. But showing at least 85. Another strong low here out in the central Pacific. Here are the jet streams of the eastern world. The jet streams of the western world, the Americas. Strong anticyclone here near the North Pole. Surface winds of the western world look like this as we have a low loitering off the coast of Newfoundland. Surface winds of the central world are like this. And here are the jet streams. Let's show some forecasts and some other data. Here's a shortwave radiation map for the Americas. It shows clouds and fog. And a large portion of the northwestern part of the U.S. encased in fog at the moment. That's the 3.9 nanometer NASA Interactive Weather Satellite Suite. And here's your US weather.gov map. Weather.gov. Some flood watches there in green. Some high surf advisories there in Hawaii. And a huge portion of the Northwest there with fog advisories. If your county's lit, click your county at weather.gov. We don't have time to go over all of that. It's a little too much. And since we do have some flood watches, let's take a look at the total accumulated precipitation forecast. So there's the total accumulated precipitation in inches. It looks like the majority of the rain expected to fall there in Nevada. Expecting over 3 inches of rain there in the southeastern portion of Nevada. That's your GFS 72-hour total accumulated precipitation forecast shown in inches. And let's move on. Here's your windy.com pressure map. Huge low there off the coast of Newfoundland. Here's your NASA GOES lightning mapper. Heavy amounts of lightning there in Arizona for the past about 10 hours. And how about a real-time lightning map? And Connecticut. Hey, New Haven. There's thunder rolling in. Thunder rolling in there to New Haven, Connecticut. Also Waterbury. Looks like also some lightning there east of Detroit in Lake Erie. Anyway, that's your real-time lightning map from lightningmaps.org. Here's your U.S. Doppler radar map as we close out the video. As it continues to precipitate in southern Alaska. Do you think the rain will hurt the rhubarb? The answer is, not if it's in cans. Here's a shortwave radiation map of the lower 48. Foggy conditions in the northwest. And a strong low there over Lake Erie. You'll be able to see that great in the water vapor map. Some heavy convection happening here in the Atlantic seaboard. You can see a lot of cloud nucleation suddenly happening there. Some warm water leading to some rapid evaporation and cloud formation. Here's a recap. U.S. Doppler radar. Rain stretching from El Paso up to Oregon. Some scattered showers there. Here's the shortwave radiation map showing clouds and fog. It's 3.9 nanometer infrared radiation from the NASA GOES satellite. And there is the water vapor map as that low continues to slowly make its way toward the east. And that is where we'll have to end things. Thanks for tuning in to the Smash News Network, least busted name of news, where we cite facts. We laugh at propaganda, fraud, and nonsense on the internet. And may that solar wind be at your back.